All right, so thanks for coming to this talk. I know there are a lot of interesting talks, so thanks for choosing this one. So I'm going to talk about search, more specifically about how to deploy one within an organization. Okay. So in today's talk, I'm going to cover these topics. So it all started with engineers using multiple content management tools. And I'm going to talk about how searching became a problem and how we use an OSS tool to address that problem, and the name of the tool is Fess, and how we overcame some of the problems with Fess. And I'm going to touch on contribution side of the project, and I'm going to share some insights and observations. Okay. So here's the list of chapters, so let's go. So just quickly, me and the team. So I'm an engineer at Toshiba. I've been recently maintaining the company's cloud infrastructure and just trying to increase the scope and range of automation through these activities, because otherwise, without increasing the automation, we are kind of doomed. But more importantly, here's the list of very capable, hardworking engineers that made this project possible. So I have a huge respect to them. So now onto the background. So in large corporations like ours, we typically have lots and lots of companies. And our team's job as software engineering center is to deploy and provide tools to other Toshiba companies, like product development departments and R&D departments. Now, we have about 200 units of deployment, and we have these tools that are basically sort of heavily OSS-based. And now let me quickly turn on the user pointer here. So we have a few more, but these four are like a core of our tools. So now, as we diversify with the tools, the searching became increasingly a problem. And there were two major reasons. For one thing, there is no easy way to search laterally. That is, sometimes we want to search all of these places exhaustively to make sure that we're not missing anything. But there's no easy way to do that. And one more problem is that, as we found out, these tools are not quite cut out for searching inside certain binary files like PDF files and Office document files, which are really like something we use quite often. So what all of these lead to is that ideally, what we want is single search box that, given a query, searches all the places and really no matter where they are and where the documents are and what the formats are. So that's what we are going for. However, this is going to be a daunting task though, because such a tool would have to be not only be able to solve the two problems that I talked about, but would have to have you would have to come with all the essential features, both on the user side and on the admin side. That is, we have to be able to easily set up crawlers and all those things and run them and maintain them easily. So, but there is a tool specifically designed for this task, and the name of the tool is Fess. So next, I'm going to quickly talk about what this tool is and what it's like to use it, as I don't think this is particularly a well-known tool. So Fess is, as README on the GitHub repo says, a powerful but easily deployable enterprise search solver. So an enterprise search here describes software for searching information within an enterprise, as opposed to web search like Google and DuckDuckGo. Now, Fess uses Elasticsearch as its search engine, meaning that indexing certain binary files, like Office files and PDF files, are more or less automatic. And one notable feature of this tool is that it comes with several types of web crawlers. There's one for web pages, and there's also one for file system, like a directory hierarchies. And there's one for a database as well. And all of this is to get data from many different kinds of sources. And if you look at the screenshots, there is a search box, and also they have admin console, and the search engine results page looks already familiar to many, I think. And this tool is developed by a company named CodeLibs, which is a company that develops an open sources tools, and they have a lot of experience engaging with OSS community. So, and let's take a quick look at how this tool works by looking at one of its core features, which is a web crawler. And I think it's a web crawler is basically a backbone of this whole system. And I think the concept is familiar to everyone. It basically crawls and indexes web pages, web page contents, and uploaded files. So the way you create web crawlers on Fess is you go to admin console and then set these parameters for web crawlers. Now, there are quite a few parameters here, but I'm going to focus on a few important ones. And first, there is, of course, URLs field. And then you can include and exclude certain URLs. Fess respects robots.txt, but certain robots.txt file doesn't disallow certain not so relevant pages. So in this case, in that kind of case, this comes in handy. And there are also fields like depth and max access count, which you probably want to set to a very high, large value, so that crawl is not going to stop prematurely. And then we came to the permissions parameter, and I think this one needs a little bit more expansion. So this parameter is where you can implement per user access control. That is, when you, I hope the font is large enough, but when you list users like that, and let's say the crawlers index everything and search is ready, then, and the users search something, only the users listed there see the results. So, but notice that this setting is per web crawler basis, meaning that if you have 100 projects on GitLab, you're going to need 100 web crawlers, which is a lot. So clearly some kind of automation is necessary, and I'll get back to this point later. One more thing to mention here is that username here can be either users on Fess. Fess has its own users and groups, but can also be users authenticated via LDAP directory service. There's an option to configure this on Fess. So I hope that gave you the some feel on how things work on Fess. So let's move on to the customization part of this talk. So no tools are perfect, and Fess is not an exception. So we have to customize and patch Fess in a few ways. So just quickly, here's a list of patches. So our dev team engineers over time wrote more than a few patches. And the general quality improvement patches and bug fix patches have been merged upstream, but there are also more like experimental and patches that are very specific to our problem. And those are kept proprietary. And I'm going to talk about two of those patches. First one is the authentication for web crawlers. Now, most of the pages of GitLab and Redmine are behind login pages. And Fess has, so the web crawler has to authenticate itself as it makes its way. Now, Fess has a mechanism for this. That is, you can create web authentication object and attach it to each web crawler. This, works in some cases, out of the box, if the login form page is fairly standard. But our GitLab is, uses SAML, and then as it turns out, Fess does not support this. We have to do some patching. To just go over how the patching works at the conceptual level, what we did is we defined extra optional parameters that admin can write on the console. That is, if there were parameters starting with some underscore, the patched parser of this form is going to pick them up and store them. And later, web crawler is going to see these parameters and recognizes that some authentication, some login needs to be attempted, and runs extra SAML specific logic. So that's the patch 1. And then the second one is about repository contents. So many of the repositories we have on GitLab are several gigabytes in size. So and both GitLab and Redmine have pages to view repository files. So in theory, if you wait long enough, web crawler is gonna index all these contents through those pages in theory. But this turned out to be a complete non-starter because just because it's too slow, and quite understandably so. And the reason is it's just so the web crawler is going to make HTTP request, and GitLab fetches the file, just one file from repo, and then renders it to the web page. So there's just too many steps to just get the content of one file. So what we did is to first clone the repository contents to local file system, and then run Fess's file crawler, which is a crawler for directory hierarchy, and do everything locally. Now, this more or less solved the problem of speed. But one problem is that since everything is done locally, when the search indices are stored, the paths are the file system paths. So we had to remap these to the URL so that later, when the user clicks a link, it takes the user to the repository file page on GitLab. So what we did is, again, we defined custom optional parameters that the admin can write on the console config parameters field, specifically this prefix URL and map URL parameters. And when these parameters are present, the parser is going to pick them up, and then later the web crawler is going to see these parameters, and then if these are present, it will perform remapping. So this is the conceptual overview of how this patching works. So, yeah. And now most of these parameters are related to the WebDriver client on Fess, and there's information about this WebDriver client and Fess 14 issue, as since the WebDriver client is sort of like discontinued on Fess 14, and Fess 14 is latest, and Fess 14 has playwright-based crawler, which is still in development, and the information in the appendix. Now I'm going to talk about another important subject, and which is automation. And as you might have guessed, our configuration grew more and more complicated, as it always does. So for instance, we have way more than quite a few configurations for each Fess instance, and so there are lots of manual edits of config files, but these are taken care of by Ansible and Dockerfile, and I think that's standard. But perhaps more interesting instance is we have to create several hundred web crawlers per Fess instance, and the reason is typically on GitLab you have projects and For in each project, you have members. And what you want to make sure is when user searches something, the users see only the resources they have access to. And so to automate the creation of web crawlers in such a case, Fess has APIs, just like GitLab APIs. So to explain how this is handled, to look at the sample script, you can kind of combine the GitLab APIs and Fess APIs. First, you can use GitLab APIs to get all the projects. And then for each project, you can get the list of members. And then for using that list of members, you can create web crawler. And this is where Fess API comes in to create web crawler. And then you can also create web authentication object and attach it to that web crawler. So the Fess APIs are mostly like GitLab APIs, and for those who have used them, I think they'll be fairly intuitive. So that's the quick intro to the Fess APIs, and I'm going to share some insights and observations that I can make. So the first is, did Fess solve our problems? And the answer would be definitely yes. So the users can now search across tools and inside binary files. And this turned out to be quite powerful as, for instance, even if the file is like a docx file, or even if it's a legacy doc format, and even if it's in a very obscure location, in a very old repository, deeply nested places, users can actually find texts inside the file. So this turned out to be quite powerful. But it's not without problems, though. So one problem is the performance. If you want to index contents of GitLab, which have, say, several hundred projects and several thousand issues using Fess instance running on this level of computing resource, it takes us about a couple days to index everything. And this is something we are trying to improve on, like how to incrementally index contents and using like some other techniques. But for now, that's it for this talk. So thank you so much for listening, and I want to open this up to the Q&A session.
So, any question?
So you have a different type of resources, right?
Yes.
So every resource has different properties, I guess. So are you indexing the same properties for every source? Do you have a set of properties to index? Are you only indexing content?
So I'm trying to understand the
so
question.
when you're indexing documents, you are indexing the content of the document, the text of the document?
Yes.
Or are you indexing also some other properties like the name, the title, the author,
I would say yes. I think so. I think let me repeat the question. The question is whether this Fess indexes only the contents, like the text inside the file, or does it index things such as metadata, like title field of PowerPoint, or they have several metadata. Yes, it does. It indexes those metadata as well, and those are handled most likely by Elasticsearch. But yes, on those metadata are indexed, and actually it shows the metadata title if they are present on the search results page.
Yeah.
So
okay,
yeah,
that's
yeah.
fine.
Mostly.
That's fine. And,
I guess,
and
yeah.
the second one is a quick one. So, are you accepting contributions to the project? It's an open project, and you are accepting contributions and new plugins.
Sorry, I'm trying. Okay, so your question is whether we are accepting contributions to the. Sorry, not for on our side. I don't quite think so. Like
so you have a catalog of connectors to Office and so on, to Elasticsearch and so on.
Yeah.
So for instance, I was thinking on CMIS, that is a standard for content management. So I was thinking of trying to contribute this new connector to the Fess project. Is that an option?
I'm sorry. I'm trying to understand the question. Like, so you said something about the connectors, right?
I'm naming that connector, but I don't know if connectors is the right word for you. I mean, you have a specific crawler for every different system, right? You have a crawler for Elasticsearch, a crawler for Office, a crawler for set of systems, right? So we can add new crawlers for different systems.
Yes. I mean, Fess has several different crawlers for different types of resources, and so the question is that are we accepting like new types of crawlers as contribution? Is that the question?
Yeah, it's more or less that.
We're kind of like a sort of like a corporation and then working as a on our side working as a like a project inside the corporation. So we by ourselves are not at the moment accepting like a contribution to the project, but yeah. So
okay, perfect. Thanks.
Another question?
Yeah. Are you going to publish the slides that you presented?
Okay.
The slides that you presented, are you going to publish them somewhere?
They are on the web page.
Yes.
PDF already.
Yeah, they're on FOSDEM website, so you should be able to download them. I'm sure I probably do.
Just a short one. You said indexing takes about several days for this project you have.
Yes.
What about re-indexing? So if content change, is re-index all the time a new index, making the whole index new? Or is it fast to just re-index certain documents?
So the question is, let's say, after index everything, and then in the subsequent run of web crawlers and then like what kind of crawlers, are they updated incrementally faster, or do we have to re-index everything? So the Fess tries to sort of crawl and efficiently. That is, it tries to ignore the contents of web pages that haven't been updated. It checks the I think the last modified field, but so the mechanism of incremental crawling is not very sort of it's not very ideal. For instance, the last modified field are it's not quite well enforced. For instance, only the certain types of static web pages use it, and so it's so there are a lot of unnecessary re-indexing happening, but there are some mechanisms to only index things that have been updated. But I gotta say that mechanism is not very well run, and there are a lot of re-indexing subsequent crawling is not not as efficient as we want, and then it is yes.
Okay, thank you very much. Thank you very much, Takashi.